The last lesson we were talking about science denialism, and we know that denialism is uh, usually harmless but can be harmful. And in the areas where denialism is harmful to us, uh, it would be nice if we could cure that problem in society and act together as a society to address these issues that face us. Which is why today I would really like to talk about science literacy, at least just for a few minutes. And science literacy is a it is understanding. It is an understanding of how science works. And it's really a way of thinking. It is to acknowledge that the scientific process, it does have some reliability. Again, we covered this in the last lesson. It's a self-correcting process. It can be duplicated. The evidence is available to everyone. There are no sacred ideas. And that critical thought, that component of approaching particular issues or ideas with the attempt to disprove. Um, that lends that great deal of reliability to the scientific process. And so, science literacy is not to say an individual should or even could understand everything in all aspects of science. Even scientists who dedicate their working lives to a particular area of science can't stay on top of the latest developments in their own field, let alone know everything in science. But it's not overly difficult, especially in the age of public education, for an individual to know maybe a little about the various areas in science. Let's call this topics, maybe scientific topics. Um, you know, maybe understand a little bit about how life functions at the cellular level. Take a biology class. You're going to do that at some point in your life, unless you live in a cave or being raised by people in the backwoods and taught only to speak Klingon. You're probably going to end up in a class and take a biology class. Take a physical science class, learn a little bit of physics, a tiny bit of chemistry, maybe even a touch of astronomy. I recommend tons and tons of astronomy, but that's just me. Understand a little bit about how these disciplines function and what we have learned from them, but most importantly is to understand how science works, which is what we've spent the last couple of lessons talking about. Um, we from an observation, we form a hypothesis. We test that hypothesis with experimentation. If it disproves the hypothesis, we need a new one. If it does not disprove the hypothesis, we want to share that information, publish. Let others test that hypothesis. Let them come up with new ways of testing that hypothesis. Um, so when we understand how science works, it allows us to approach issues in an informed manner. Uh, Science literacy is quite literally the antidote or the cure for science denialism, because it turns out that when people understand what science is and how it works, they are less likely to refuse to accept its conclusions without evidence. You don't find people who understand how science works standing in Walmart screaming in the faces of minimum wage employees about having to wear a mask. Um, you don't find people who understand how science works um, stating at the top of their lungs that the earth is flat and astronauts never reached the moon and those types of things. So science literacy, it is the cure for science denialism, but definitionally, it is an understanding of how science works. And so beyond simply being a cure for science denialism, why science literacy is important? Okay, it is important for a couple of reasons. And the first reason would be you, with science literacy, you are in a position to make an informed decision on any issue regarding science, and there are more than a lot of people realize. So you can make informed decisions. On issues in science. So you're not guessing. You're not basing your decision on what your uncle or your aunt said on their Facebook page. You're not basing your decision on the random discussions from coworkers. You're basing your decision in an understanding of what this issue is and what the data means. That allows you to make an informed decision. I think that would work better for everyone. I think we can all agree that understanding reality helps you make better decisions. So that would be the first reason. And the second reason, and this is especially important today, particularly in the United States, um, an informed democracy, an informed citizenry is necessary for a democracy to function, and I would argue even to survive. Now, we understand what a democratic form of government is, or a democratic republic like we have in the United States. We decide as a body of citizens what the direction of our nation is. Um, we decide, or our elected representatives will decide, very important issues. How do we address issues in science? How do we address things like global climate change? How do we address things like, I don't know, speculating here, some viral pandemic? Um, these issues are scientific in nature, and an informed citizenry um, is absolutely necessary in order to confront a lot of these issues. So, for these two reasons, guys, science literacy is particularly important. Understand how the process works, right? Know what the scientific method is. Understand a little bit about that. Understand what it means to be supported by evidence. Understand how compelling it is to be able to predict things before they happen. This is what theories do. They are predictive. These are very powerful statements, and opinion simply doesn't stand up to them. So, how do we cure science denialism? Well, science literacy is really the only way, and that means good public schools and a citizenry that wants to know things, wants to understand reality, is interested in the truths that we learn from experimentation and skeptical thought. Um, so I recommend a good dose of science literacy, guys. This is really going to change the way that you see everything. Um, okay, this first objective, science literacy and why it's important. Second thing I want to talk about, just briefly, is why do we do science the way that we do science? And in other words, why is it that the scientific method is our way of approaching issues? Uh, I guess one argument would be that because it works, it determines what is true better than any other process or method that humans have ever come up with. But more fundamental than that, why do we do science the way we do? And I think the answer is a little bit more fundamental than that. Um, I would argue that the process of doing science is really a formal application of the way our brains function. Um, the scientific process is how human beings appear to be wired to approach problems or questions or seeking an explanation. It appears that way. It appears as if human brains just work that way. Um, and this approach is not, please let me clarify, it would be hypocritical of me to talk repeatedly about science and not point out the fact that this section uh, um, is opinion. This is not fact. This is just me speculating for pure entertainment purposes. And why do we do science the way that we do? And my argument is that it appears that that's just how our brains work. And now, if you'll allow me, I'll just do a short little hypothetical situation to try to illustrate this. Um, I have a motorcycle, and I went out to ride this bike the other day, and it wouldn't start. And the engine would turn a little bit, just wagga wagga, it wouldn't start. So my bike wouldn't start. And so right away I thought, well, maybe I ran it too low on fuel. Maybe I'm out of gas. And so in order to check that, the easiest thing to do is pop open the gas tank and look. And well, as soon as I popped open the gas tank, I could see that there was plenty of fuel sloshing around in there. So I checked the gas tank, and it had a bunch of fuel in it. So my idea that it was out of gas was wrong. And so I thought up a new reason. Maybe it's not out of gas. Maybe the battery needs to be charged. So think up a new idea. Maybe the battery just isn't carrying enough charge. Not cranking enough amps to turn this engine well enough to get it to catch. So, new idea, battery is low on charge. And I hooked it up to a charger and a voltmeter on it. I could see that it was a reading a little bit low. I had nothing ridiculously low, but it was a little bit low. So I ran the charger on it for a few minutes, and and then I gave it a start, and uh, fired right up. I run the charger, and the engine starts. Fantastic. So now I can go for a ride. And make sure you wear your helmet, boys and girls. I used to not wear a helmet, and then I learned physics. Um, go for a ride. Uh, I probably um, wouldn't make a big fuss out of it. I wouldn't write an article about my doggone battery needing to be charged, but I'm going to tell somebody. I may complain to my wife. I might tell a friend. I'm certainly rambling about it right now. In one way or another, word got out. My doggone battery didn't work. And I'm probably not the only human being who has experienced this issue. And others will experience it as well. And, you know, for any other human being whose battery isn't sufficiently charged, their engine won't start either. And pretty soon it becomes well established and unquestioned um, that dead batteries don't start engines, right? Dead batteries, no good. Now, this is a rather informal situation I'm describing here, but let's see if this makes sense. Guys, I had a problem. My bike wouldn't start. And so I formulated a hypothesis. I attempted to come up with a solution that could be tested. My gas tank was empty. I tested it. When I opened my gas tank, that's called experimentation. And the experiment disproved my hypothesis. The fuel tank is not empty. I formulated a new hypothesis. My battery needs to be charged. The experimentation where I tested that hypothesis was when I put the voltmeter on it and charged the battery up. Um, Now, since I'm not a professional scientist, I didn't publish this, but this really just means to spread the word, and I did that, even to people who didn't want to hear. You think my wife cares about my motorcycle battery? I can assure you she does not. Um, Others experiment. Hey, if anybody in the world, trust me, if anybody in the world had figured out how to make dead batteries start engines, they would have spread the word, tried to market it or something, and they would not have hesitated to disprove the idea that dead batteries don't work. That's never happened. Um, and now, with much evidence, many experiments to support it, it is an emergent truth that dead batteries don't start engines. Now, this is a very simple scenario that functions just like the scientific method. It is how we approach the world. Every problem that you deal with that you must solve requires a hypothesis. You can't simply wish a problem away. If I said my bike won't start and I think it's because it doesn't have enough magic, um, I can't think of a way to test the magic in a motorcycle. It's untestable. If it can't be tested, it's not science. That's why magic isn't part of the problem here. Another way to look at this. One more simple analogy. I promise I'm finished after this. Um, Ken goes to school and he spots Barbie. And Barbie Barbie looks adorable. And so Ken wants to go on a date. And he hypothesizes that Barbie will go out if he asks. And he asks Barbie to go on a date, and Barbie shoots him down. And she says, "I'm sorry, I would go out on a date with you, but your breath is really bad." And so Ken has hypothesized, if I ask Barbie out, um, if I ask her out, she'll say yes. And he experiments. He asks her out, and she says no, shoots him down. He needs a new hypothesis. I need to brush my teeth. He brushes his teeth. His new hypothesis is, with fresh breath, Susie will say yes. He experiments. Susie says yes. Now, Ken will probably not publish like a professional scientist will, but you can bet he's going to tell his buddies that he's got a date with Barbie. All right? He has spread the word. Others will experiment. Other young fellas are going to ask their ladies out on dates, and they will gather their own evidence. And sooner or later, it's going to become an accepted emergent truth that bad breath is detrimental to your dating life. Um, there's the theory of bad breath and bad dating. So, guys, my argument here, why does it work? Well, because it's reliable, and we are an extraordinarily lucky species to have brains that work this way. Another argument that I would make, which may or may not have some scientific basis behind it, is that this is also what separates us from every other animal on the planet. Uh, you know, the fact that we have a hardwired brain to do science is why we drive cars, and we don't live in caves and chuck stones at each other over the nearest dead carcass. This separates us from every other species on the planet. This is our version of being able to sprint 60 miles per hour, or having fangs and claws or armor. We don't have any of that. Squishy little humans. All we have are brains, but guess what? We can do science.